Hello students, welcome you all to the session on Solutions of GATE 2022 Civil Engineering subject Fluid Mechanics. When we are going with first question of GATE 2022 1 mark in Fluid Mechanics, the dimensions of dynamic viscosity is M L inverse T inverse, B M L inverse T power minus 2, C M L power minus 2 T power minus 2, D M L naught T power minus 1. Now, when we see the dimensions of dynamic viscosity, resistance offered by one layer of the fluid onto its adjacent layer, we call it as dynamic viscosity. For Newtonian fluids, shear stress tau equal to mu into du by dy, where du by dy is called shear strain rate or rate of shear strain, and mu is coefficient of dynamic viscosity. So mu is equal to tau by du by dy. I will be writing in this way. Stress is force per area. Du by dy will be length by time, and distance is 1 by length. This is how I will write du by dy, velocity gradient. So obviously, on simplifying this, we get force into time by length square. So we will be getting force F is ma, mass into acceleration is velocity by time, right? That is mass into length by time I can write mass into velocity is length by time. So obviously, what will be the unit of force here? M L T power minus 2, right? Whereas dynamic viscosity mu is equal to force M L T power minus 2 into time T by length, that is L square. On solving this, M L inverse T power minus 1. This will be the dimensional unit or dimension of dynamic viscosity. M L inverse T power minus 1. That is option A will be the appropriate right answer for the given question. Hope you people have clearly understood. Very easy, simple question, 1 mark question, most of the times asked in your competitive examinations. Moving on to the next question. Question number 2. A pump with a efficiency of 80% is used to draw groundwater from a well for irrigating a flat field of area 108 acres, 108 hectares. The base period and delta for paddy crop on the field is 120 days and 144 centimeters respectively. Water application efficiency in the field is 80%. Lowest level of water in the well is 10 meter below the ground. The minimum required horsepower of the pump is dash, round off to 2 decimals. Consider 1 HP is equal to 746 watt. Unit weight of water is 9810 Newton per meter cube. So this is a question from pumps. When you see the solution, in the question he has given the base days are 120, base period is 120 days, delta around 144 centimeter. When converted, you will get 1.44 meter. Duty is around 8.64 B by delta. This is the formula. So 8.64 into 120 by 1.44. You will get around 720 hectares per cubic. Now, Q is equal to area by duty. Area is 108 and duty is around 720 hectare per cubic. So you will be getting around 3.3 by 20 meter cube per second cube. So we write discharge applied is equal to Q by efficiency. 3 by 20, efficiency is 80%, this is 0.8, which will be 3 by 16, which will be 3 by 16. So this is your applied discharge. Now he is asking you power. When we talk about power for a pump, it is mgh by T, that is density into volume by time, right, into G into H. Density is equal to mass by volume. From there I have written this, that is rho Q G H gamma Q H, because rho G is gamma. When we substitute 9810 into 3 by 16 into 10, which you will be getting it around 73575 by 4 watt. But he has given horsepower of pump is power by 746 into efficiency. Power is 73575 by 4 into 746 into 0.8. When you substitute, you will get an answer of 30.82 HP horsepower. 30.82 HP. So this will be the appropriate answer for the given question. So he is asking you to round off to 2 decimal places. 30.82 HP will be the answer for the given question here. Moving on to the next question. Question number 3. Two discrete spherical particles P and Q of equal mass densities are independently released in water. Particle P and particle Q has a diameter of 0.5 mm and 1 mm. Assume Stokes' law is valid. The drag force on a particle Q will be dash times the drag force on the particle P. Round off to the nearest integers. Generally, in case of discrete particles settling and the Stokes' law is getting validated at terminal velocity, students. Since there will be no change in velocity, the net force on the body will be how much? 0. So obviously, when we solve this question, we will be writing like weight force of sphere minus buoyant force will be equal to drag force. So what happens whenever we talk, this is the sphere, weight force will be acting downward, buoyant force will be acting upward, velocity terminal will be downward, drag force will be upward. This is the condition. And for that, I'll write drag force Fd is equal to sphere pi by 6 d cube density G minus pi by 6 d cube minus density of the fluid into G. So obviously Fd, take pi by 6 d cube into G common, rho is surface and fluid. Density of the medium and density of the sphere will be constants. So drag force here will be directly proportional to d cube. Generally, for a particle he has given a diameter of 0.5 mm and for a particle Q he has given 1 mm. That will be force of drag on particle Q, force on drag of particle P will be diameter of Q cube by diameter of P cube, which will be 1 by 0.5 whole cube, which will be around 8. So drag force of Q is equal to 8 times drag force of P. So answer will be 8. 8 times the drag force. 8 times the drag force on particle P. So the answer here is 8. These are the questions from fluid mechanics of GATE 2022. Thank you, students.